Quantum entanglement is one of those scary phrases. You'll often hear about things like the wave function, superpositions, or spooky action at a distance. In this video, we're going to talk a bit about what entanglement is, without resorting to any deep physics or mathematical formalisms. A quantum mechanical system is a lot like a coin toss. Imagine, if you will, tossing a coin up in the air. If the coin is fair, it can either land heads or tails with equal probability. Now let's do the same with two coins. We should see four possibilities. For example, one coin is heads, the other tails. Or perhaps the first coin is tails and the other heads. Or maybe both are heads, or both are tails. Note how getting a heads on the second coin is totally independent of the first. Knowing that the first coin is a heads tells us nothing about the second. What if our coins are truly quantum mechanical? What if we let them interact in some way, for example by rubbing them together before we toss them? In our macroscopic worldview, we would expect this to change nothing. We expect that each coin will turn up a heads or tails, regardless of whether the other coin were heads or tails. But once we introduce quantum effects, things are not quite so simple. If we let our quantum mechanical coins interact in just the right way, something strange happens. Imagine, if you will, doing a series of repeated flips of both of our quantum coins and recording the result. For example, we get heads heads, heads tails, and tails heads. We continue like this for another few rolls. We notice a strange correlation forming. Whenever our second coin is tails, the first coin is always heads. The fate of the first coin has become entangled with the second. By simply looking at the second coin and seeing that it's tails, we already know the other coin is heads without even having to look at it. That is the effect of quantum entanglement. Now, how could this be useful? Two friends, Alice and Bob, meet and split an entangled system among each other, as friends do. They part ways and each heads home. Alice suddenly remembers she forgot to give Bob a quantum coin. No problem. Through an ingenious scheme, she figures out a way to send it to Bob by measuring both her coin and her entangled system at once. Depending on how the coin flip came out, she can message Bob through her computer, and with those details he can reconstruct the quantum coin where he is. Note, by doing so, Alice has removed the quantumness from her coin. In a way, the coin has disappeared in one location and reappeared in another, a kind of teleportation.